Applications of equations in real life. Today, we will learn application of equations in real life. So far, we have learned to solve equations. Let's recall it with the help of an example. Solve the equation 3x minus 14 is equal to 34 and find the value of x. Let's solve this with the help of the transpose method. In the given equation, the variable x, that is 3x, is in the LHS, from which 14 is being subtracted. After transposing 14 to the RHS, it will be added to 34. So, we will get 3x in the LHS and 34 plus 14 in the RHS. 34 plus 14 is equal to 48. So, we will get 3x is equal to 48. In the LHS, 3 is getting multiplied by x. So, in the RHS, 48 will be divided by 3. Therefore, x is equal to 48 divided by 3. 48 divided by 3 is equal to 16. Thus, x is equal to 16. In this lesson, we will see how equations can be applied in our daily lives. Suppose you are the last batsman in your cricket team. The other team scored 150 runs and your team has scored 112 runs so far. How many runs would you need to win? Can you represent this situation using the algebraic form? Let's do it together. Suppose you need to make x runs. Here, x is a variable and its value is unknown. If the score of the other team is 150 runs and you score 150, then the match will be a draw. But in order to win the game, your team needs 151 runs. If we represent this situation in algebraic form, the equation would be runs made by your team plus number of runs you need to score is equal to 151. That is, 112 plus x is equal to 151. In order to find the value of x, we have to solve this equation. Here, we will transpose 112 from the LHS to the RHS and it will become minus 112. Therefore, we will get x is equal to 151 minus 112. 151 minus 112 is equal to 39. Thus, we will get x is equal to 39. If we put the value of x in the LHS of this equation, we can see that this solution is correct. That means you need 39 runs to win the game. So friends, today we have learnt the applications of equations in real life. In the next video, we will solve some more examples related to this. Thank you. Application of equations in real life with examples. Today, we will see examples related to application of equations in real life. Example 1. You have 100 rupees to shop at the market. Suppose you bought pulses for X rupees and the price of vegetables was 15 rupees more than half the price of pulses. After shopping, you're left with 10 rupees. Can you tell the cost of pulses? Given that the cost of pulses is X rupees, the cost of vegetables is 15 more than half the cost of pulses, which is x by 2 plus 15. And we're left with 10 rupees. We know that the total amount is equal to cost of pulses plus cost of vegetables plus the remaining amount. Therefore, our equation will be 100 is equal to x plus x by 2 plus 15 plus 10. 15 plus 10 is equal to 25. Now, how do we add x and x by 2? We can show it like this. Take the LCM of 1 and 2 to get 2. Dividing and multiplying x by 1 by 2, we will get 2x by 2. Now, we can easily add 2x by 2 and x by 2. Taking x as common, we will get 3x by 2. So, our equation will be 100 is equal to 3x by 2 plus 25. In order to find the value of pulses, we have to solve this equation so that the value of x will be known. In this equation, we only need the term of x in RHS. So, we will take 25 from the RHS to the LHS and plus 25 will become minus 25. Our new LHS will be 100 minus 25. Our new RHS will be 3x by 2, which means our equation will be 75 is equal to 3x by 2. Now, instead of 3x by 2 in the RHS, we need only x. Since 2 is dividing 3x in the RHS, it would multiply in the LHS. Our new LHS will be 75 into 2. Our new RHS will be 3x. Therefore, our equation will be 150 is equal to 3x. In order to find the value of x, we now divide the LHS by 3, since 3 is multiplying x in the RHS. Our new LHS will be 150 by 3 and our new RHS will be x. Therefore, our equation will be 150 by 3 is equal to x. That is, 50 is equal to x. Sometimes there is a misconception that numbers are only in the RHS and variables are only in the LHS. But that is not true. Instead, even after exchanging both sides, they remain equal. Just like both 50 is equal to x and x is equal to 50 are the same. By placing the value of variable x is equal to 50 in the RHS of the equation, you can verify that this solution is correct. So, the expected answer would be 50, that is, the cost of pulses is 50 rupees. Let's understand another example. In your school, suppose the number of boys in class 7 is 6 more than double the number of girls. If the total number of boys in the class are 30, then what will be the total number of girls? Can you tell me what the equation will be? Let's solve this question. If we suppose the number of girls in the class to be A, then the number of boys is equal to 2A plus 6. In our question, it is given that the total number of boys are 30. Then, our equation will be something like this. 2A plus 6 is equal to 30. Let's solve it and find the total number of girls. As we have learnt, to solve the equation here, we have to keep only the terms of A on the left side. So, we have to transpose 6 from the LHS to the RHS. By doing so, our new LHS will be 2A and our new RHS will be 30 minus 6, where we get 2a is equal to 24. To find the value of a, we will divide 24 by 2 in the RHS. Our new LHS will be a. Our new RHS will be 24 by 2. That is, a is equal to 12. Therefore, the total number of girls in the class will be 12. Today, we have seen examples related to application of equations in real life. In the next video, we will understand some misconceptions related to them. Thank you. Application of equations in real life. Misconceptions. Today, we will see the misconceptions related to application of equations in real life. So far, we have learned to write equations and apply them in our daily life. We understood them with examples. Now let's look at some misconceptions related to equations. We often look at any equation and think that the RHS is the answer to the LHS, whereas an equation makes a relation between the LHS and the RHS. Observe the given equation carefully. Which of the following options is correct? We cannot divide an equation as a question and an answer. Therefore, the first option is incorrect. The second option, we already know that the LHS is on the left side of the equality sign and RHS is on the right. But in this option, 2x plus 19 is called as the RHS and 25 as the LHS. Therefore, the second option is also incorrect. Third option, while understanding the second option, we have revised that the LHS is on the left side of the equality sign and the RHS on the right. In this equation, 2x plus 19 is on the left-hand side, that is LHS, and 25 is on the right-hand side, that is RHS. Therefore, the third option is correct. Fourth option. Since we have come to know that the third option is correct, it means that the fourth option is incorrect. While transposing the term in an equation, children often make mistakes in the operation of division and multiplication. Let's look at this example. Vijay's age is 7 years less than half of his father's age. If Vijay's age is 14, can you tell his father's age? Can you represent this condition as an equation? Suppose Vijay's father's age is A years. Then our equation would be age of Vijay's father divided by 2 minus 7 is equal to age of Vijay. That is, A by 2 minus 7 is equal to 14. In order to find the age of Vijay's father, we have to solve this equation. In this equation, we only need the terms of A in LHS. So, we will transpose minus 7 into RHS, which will be added with 14 in RHS. Hence, we will get A by 2 is equal to 21. To solve this equation, we want just A in LHS. Here, A is divided by 2 in LHS. Many times, while solving an equation, children divide RHS by 2. So, they get A is equal to 21 by 2, which is incorrect. In LHS, if 2 divides A, then to find the value of A, it will be multiplied in RHS. So, we will get A is equal to 21 into 2, that gives A is equal to 42. Therefore, our answer is 42. This means the age of Vijay's father will be 42. Today, we have seen misconceptions related to the application of equations in real life. Hope you've understood this lesson well. Thank you.